So this problem is about force analysis. So essentially force analysis. Okay, so let me copy. And it's an helical gear. So based on the data that the problem provides, we will need to calculate some other variables or parameters. So I will copy the equations that we require. So I go back here to nomenclature and let me go through the book. So in parallel helical gears, and I will copy these equations that we are going to require. So this one, let me close something here, this one. This other, these are for the pitch, normal and axial pitch. This one, normal diametral pitch. This one about the angles. We have 3 angles in helical gears, normal, transverse, and the helix angle. And also in the solved exercise, this one for the diameter of the pitch circle. Does someone already start to record the session? If not, could you start to record the session?
Yes, teacher.
Okay, thank you.
Christian, sorry.
Okay, so let's look into the problem. So we have this arrangement of helical gears. And for pinion 2, here we have the input. So essentially here is the input. Let me decrease the thickness of this one. So here is the input of the power. So in this pinion 2, the data is that the input torsion is 1,200 pounds force per inch. This pinion 2 has a normal diametral pitch. So it's this one with a value of 8 teeth per inch. As well, the number of teeth in pinion 2 is 14. normal pressure angle, so this phi n, 20 degrees. And it's a right-hand helix. And the helix is 30 degrees. So that's for pinion 2. And we will need the diameter in order to calculate the tangential force. So the diameter in 2 is going to be the number of teeth over the transverse diametral pitch. So we don't have the transverse diametral pitch, but we have the normal one and the helix angle, so we can calculate this transverse diametral pitch. So let me put here that the transverse, based on this equation, is going to be the normal diametral pitch times the cosine of the helix angle. So it's going to be the 8 times the cosine of 30 degrees. And we will have the transverse diametral pitch. How much you got here? 8 times the cosine of 30.
$6.92.
Let's use 4 digits.
4. 92.82.
82. And at the 4 digit, we round it, right?
Yes.
Okay. So then this diameter is going to be the 14 over the transverse, that is 6.9282. These are teeth per inch. So the teeth cancels out and we are going to have inch. So the diameter in 2 is going to be how much? 14 over 6.9282.
$2.0207.
So that's the diameter in 2. So the torsion that we are going to have in 2 is going to be, so not precisely the torsion, but the force and the tangential, right? The tangential that 2 is applying in 3 is going to be the torsion, and the torsion is 1,200 pounds force per inch, according with the data provided, right? Over the radius, so it's going to be this diameter over 2, right? So essentially it can be this times 2 over the 2.0207 inch. So we're going to have pounds force. Could you help me with operation and tell me what is the solution? This 2 times 1,200 over 2.0207.
I got 1,187.6919.
Okay, here in the forces, we can leave only one digit. So it's 69, so 7, right?
Yes.
Aquí elegimos dejar solamente un dígito en la fuerza, porque en realidad aquí el orden de magnitud estamos en miles, ¿no? Son 1187. pues con un dígito después del punto decimal me es suficiente. Pero acá, el orden de magnitud, no estamos en miles, estamos en unidad, 2, ¿no? 2. Entonces ahí sí hace sentido tener 4 dígitos como de precisión. Okay, so this one is the tangential force. But let's look into the analysis on how this force and how all the forces in helical gears are going to be oriented or distributed, right? So essentially, in order to look into the direction of the forces, so as well we have in the Shigley's book a scheme where we have the different forces, this one, and we already see that we have radial, tangential, and axial force for helical gear, right? But this representation, it's one possible scenario. So essentially we have different scenarios based whether it's right hand or left hand, and whether if it's right hand, it's the input or is the output. If it's the input, the drive or the driven. So essentially, I have a figure here, this one. So this one can help us in order to clearly identify the direction of the forces, essentially. So in our case, we have the input in the pinion. So essentially, the pinion is a drive. So essentially, it's this initial case that is a right-hand pinion, and the pinion is the drive or is the input here. So essentially, it's this case. And from this case, looking into the direction of the rotation, it's this specific case. So I will copy that one specifically. So it's this precise case. Do you have questions or comments? A lo mejor lo repito un poco en español. De estas figuras nos podemos ayudar para los diferentes escenarios entre si es hélice de mano derecha o hélice de mano izquierda, y si es el piñón por donde entra la potencia, o si más bien el piñón es por donde sale. En nuestro caso, el piñón es por donde entra la potencia y es un piñón de mano derecha, de hélice de mano derecha. Entonces, aquí el drive, que es potencia, o el conductor, y gira en esta dirección. Entonces, este es el específico caso que corresponde. Pero pudieran, o sea, en general podrían ser todas estas diferentes versiones, ¿no? O sea, podría ser mismo piñón que conduce o que por dentro de la potencia de mano derecha, pero que en lugar de girar en esta dirección, gire en esta otra. Y ya esa es otra posibilidad. O que el piñón sea de mano izquierda, de hélice de mano izquierda. Bueno, en este caso es esta.
Cristian, ¿cómo sabes que es de mano, o sea, que es de mano derecha? El piñón.
Si colocas tu mano, digamos, aquí sobre el monitor, con la palma casi tocando con tu palma el monitor, tu dedo pulgar está en la misma dirección que las hélices.
Ok.
¿Sí lo verificas o?
No, sí, creo que sí.
It was as well, I don't know if I saved the image, but there's this let's see if we find helical gear. Yeah, this one. So if you put your hand like this one, the thumb, it's right hand, left hand. O sea, si pone la mano derecha, pues justo el ángulo que tiene el pulgar, que coincide con el de el engrane, pues este es un engrane de hélice derecha o de mano derecha, y este es de hélice izquierda o mano izquierda.
Ya, gracias, Cristian. Ahora sí.
Ok. So if I place this here, let me put it here probably. Yeah. So essentially, the pinion, it's right hand. That this one, number 2, let me put it better here. It's right hand. Do you agree that is right hand helical gear?
Yes.
Yes.
Thank you. And essentially, the direction of rotation, it's in the direction of the fingers, like the 4 fingers. If I go back to this figure, these 4 fingers are pointing in the direction of rotation, if you see in this one. So in this one, if you place your right hand, your four fingers, with the exception of the thumb, are pointing in the direction of rotation, right?
Yes.
That is the same as this case. It's pointing in the direction of rotation. So that's why this configuration match the one that we have in the problem, right?
Yes.
And what I'm missing, and let me go and copy that information, it's that, let me close this one as well. This one as well. It's what arrow is the pinion and what arrow is the gear. I will place it here. So essentially, the arrow that it's white, it's the pinion, and the arrow that is black, it's the gear. So essentially, with this configuration, the force that the axial force that goes into the gear goes to from here to the right. So essentially, with that information, I will let me close this one. Yeah, with the black. So essentially, this one, and let me put 4 here. So it's, as I mentioned, towards the right. So essentially, here is going to be towards the right, and that one is going to be the axial force. That 2, it's set into 3, or the axial force that that comes from 2 but goes to 3 in that direction. So that's in gear 3. And let's say in red, this one. So essentially, in number 2, is going to be in this other direction, completely axial, more or less. So that one is going to be the force axial, that it's the reaction from 3/2. Entonces, esta sería la dirección de las fuerzas axiales. En el engrane 3 es la fuerza axial que el 2 le manda al 3 y está en esta dirección. Y en el engrane 2 es la que le regresa de reacción. Sigue siendo fuerza axial. Fuerza axial. Ajá. Que el 3 le regresa a 2 y serían esas las direcciones para la fuerza axial. For the tangential and the radial, it's the same as an spur gear. So essentially, from this view, looking from this side, so essentially now we are looking from this side. This is the direction of rotation. So here as well, we are going to have the tangential. So it's the tangential that 2 applies in 3. And now looking into gear 3 is going to be the tangential that 3 returns to 2. So that's for the tangential. So also, if we say that this number 2 it's rotating in this direction, so that's the rotation of number 2. Number 3 it's rotating in this direction, the same as number 4, and number 5 then is rotating in that direction, right?
Yes.
So also we can identify the forces that go from number 4 to 5. So if we look into the forces that go from number 4 to 5, it's going to be a tangential, and so this tangential, that is going to be 4/5. And at the same point, the reaction, that is as well a tangential, that is the 5/4. And about the radials, so the radials always points to the center of the shaft. So essentially here, we are going to have a radial. And that one is going to be the radial force, that is the reaction or the return from 3 to 2. Here, pointing to the center of the shaft, that one is going to be the radial. That 2 applies in 3. Let me put number 1 here. So that one is that radial, right? That one. And the same in the other, 5/4, so it's that one, that it's going to be the radial of 5/4 and that one that is going to be the radial that 4 returns to 5. So those are going to be the forces, tangential and radial.
Christian, I have a
Yes.
question. I'm looking at the formula of the pitch, the transverse pitch. It is correct, and because you have here in the right side the formula here. Okay. But what is the difference between this one and the first one that you have here?
This other? That in this one is teeth
Okay.
per inch.
Okay.
And in this one, essentially is just inch. So this one, it's a circular pitch.
Circular pitch, and the other one is a normal diametral pitch.
Yeah,
Yes.
yeah, exactly. So circular pitch is, normal circular pitch in this case is just a distance, right? And in the diametral pitch is teeth per inch, right?
Okay, thank you.
Okay, and we are missing to identify the axial forces in this other configuration between 4 and 5. So in this one, number 4, this one is going to be a left-hand helical gear. So this one is left hand. And this one essentially it's the input. Este número 4 es un piñón de mano izquierda, un piñón helicoidal de mano izquierda, y es por donde entra la potencia, o sea, porque el 4 es el que manda la potencia al 5, ¿no? O sea, sería el input el 4 y el output sería el 5. So then it's going to be this case, left hand pinion as drive gear, and let's just identify